Hello and Assalamualaikum. First, I would like to introduce about myself. My name is Nur Aja Shavika binti Rosli. I am from class CS 2671B2 and my ID student is 2020859412. Okay, our group choose to do the experiment one, which is the acceleration due to gravity.
Assalamualaikum everyone. Hi, my name is Nurhan Salisha binti Muhammad Syahul. I am from CS 2671B2 and my ID number is 2020828668.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Aina Akilah binti Zulkafli. I'm from CS 2671B2 and my student ID is 2020479818.
I would like to say the objective of this experiment. The objective is to determine the acceleration due to gravity, which is G, by means of a simple pendulum. First, I would like to tell you about the intro of this experiment. The intro is knowing the value of G is important in many applications, such as aerospace field to determine the load of aircraft and spacecraft, and automotive engineering mainly in relation to submarine forces and collision analysis. Okay, there are many ways to measure the gravitational acceleration of the Earth. Two common ways to determine G in an introductory physics laboratory carried out by first, timing the free fall of an object going through certain measured vertical distance and then calculate G by using an approximate equation of motion. And second, timing the period of a pendulum for different length and then calculate G by using the formula that relates the periods of oscillation and the length.
Next, let's move to the apparatus and its usage. In our experiment, we will use stopwatch, meter ruler, retard stand, clamp, string, and the most important one, the pendulum bob. First, stopwatch will be used to measure the time taken between the first oscillation till the last oscillation. Meter ruler is to measure the length between the point of suspension to the bob, while retard stand and clamp is used together to support the apparatus during the experiment. Lastly, string and the pendulum bob. It will be attached together to form a simple pendulum, and all the apparatus we use in this experiment will be set up to find the acceleration due to gravity, G. Theory of simple pendulum experiment. In the theory of simple pendulum experiment, I will explain to you what is simple pendulum, length of simple pendulum, and time period of simple pendulum. First, what is simple pendulum? Simple pendulum consists of a heavy point mass called bob, which is tied to one end of a perfectly inextensible, flexible, and weightless string. In the experiment, we tied a metallic spherical bob to a fine cotton stitching thread. Next, length of simple pendulum. Length of simple pendulum is the distance from the point of suspension to the center of gravity of bob. It will be represented by capital letter of L. Lastly, what is time period of simple pendulum? Time period of simple pendulum is the time taken of the bob of the simple pendulum to make one complete oscillation, and it will be represented by capital letter of T. Time period of simple pendulum depends on length of simple pendulum, L, and acceleration due to gravity, G. The relationship between T L, and G is represented by equation T equal to 2 pi square root L divided by G. It is to find the acceleration due to gravity G. After we know the value of L and T squared, we will able to plot the graph of T squared versus L and find its acceleration due to gravity. And from the experiment, we will able to get the G experimental and compare G experimental with G standard and find the percentage error.
Hi everyone. Now it's my turn to elaborate the procedure to all of you. Based on the picture that appears here, you can see this is how this experiment was set up. Firstly, the simple pendulum system was set up by using retort stand, clamp, pendulum bob, and string. Secondly, the period of the pendulum for the certain length of the pendulum string was determined with the small oscillation angle. Thirdly, the data was recorded in the appropriate table. Next, step 2 and step 3 were recorded with 8 more readings with several different length of strings. G from the appropriate graph of the measured quantity was determined based on the equation T equal to 2 pi square root L over G, where T and L are the period of the length of the pendulum. Determine the uncertainty of G. The percentage difference between the acceleration due to gravity in this experiment and the standard acceleration due to gravity at the sea level, which is 9.81 meter per second square, was determined. These are the data and the results that we obtained from the experiment earlier. Table 1 shown the period of a pendulum at a different length. These are the graphs that we obtained based on the data and the results that we got. Based on the data that we got from our graph, which is y equal to 4.0233x, we can find the G based on the data that we got. But in this experiment, we doesn't have the C value because our graph, our straight line graph, didn't through the y-axis. That is why the C value in our equation is 0. Based on the equation T square equal to 4 pi square L over G, we can compare it with the y equal to mx plus c equation. So we can compare the m equation from the graph with the m from the T square equation, which is we get 4.0233 equal to 4 pi square equal to G. Then based on that equation, we can make the G as the subtract, and we finally can get the G, which is 9.815 meter per second square. These are the table of the uncertainty of this experiment. This is the calculation on how to find the uncertainty of gradient in this experiment and how to find the uncertainty of G. So, acceleration due to gravity is 9.815, uncertainty 0.122 millimeter per second square. After we obtain the G, we can finally calculate the percentage error, which is the formula is G standard minus by G experiment over G standard, and then multiply by 100%. The percentage error that we got in this experiment is 0.05%, which is really low, and the low percentage error means that we are really close to the real value. which is great.
Based on our objective of this experiment, we were able to determine the value of acceleration due to gravity g. The theoretical value represented by g standard, which is 9.81 meter per second squared, and the experimental value represented by g experimental, which is 9.815 meter per second squared, enable us to calculate the percentage error. So, the percentage error that we got from this experiment is 0.05%. Smaller percentage error means that you are close to the accepted value or real value, which is the G standard 9.81 meter per second squared. The source of this error is human error and technological error. Human error caused by student who tends to make mistake when reading the data from the stopwatch. Technological error is caused by analog stopwatch that is used during the experiment. So, to minimize the error that we got from this experiment, we can reduce the reaction time of the observer, and we can use a digital technology such as digital stopwatch to get better accuracy or better result from this experiment.